So now let's say, okay, now that we have a list, what are some things that we can do? And then here are the obvious things you want to do. So let me just talk about it, and we can, again, I'll run the code and then just talk about the code as we see it. So the first thing is, of course, you can create a list, and then you can, you can print out. So here, probably just focus on this particular syntax here by using the list with a square bracket. Notice it's a square bracket. By using the square bracket and passing a value in, you can extract any element. So for example, here the index is 0, but if I say index equals 4, it's going to print out the 4th element for me, right? So the index is 4 and the value is 5. Notice that when the index is 4, the value is 5. So that means it starts indexing from 0. And this repeats what we have seen in other contexts. Python, whenever you ask Python to start any kind of counting, always starts from 0. So remember that when you're indexing into a list, the maximum you can reach is 1 less than the actual length of the list, okay? Because it starts from 0. Again, something you'll get used to as you write some code, okay? Now, lists are actually mutable, and I'll show you what mutability means soon. But for now, I just want to show you an interesting idea. So for example, look at this. If you ask, there's an interesting function in Python called id. And what id does is it actually tells you where in memory this list is stored, right? So if you create two different lists, so for example, in this example, I have list L1 and L2. If L2 is a completely different list, it will have a totally different ID. So for example, you see the list L2 has an ID of 5, but the list L1 has an ID of 4. And you can see that even though I've added an element to the list, the ID hasn't changed. So that means the list, once it's created, is continuously growing and nothing is changing in the program as far as where the list is located. Internally, the list is expanding, but the ID of the list is not changing, meaning that it's mutable. Okay, slightly complicated way for you to see how it's mutable, but I want you to understand that you can grow a list by adding elements to it, and it's still the same list. It's not a different list. And in order to check if it's the same list or a different list, we can use this ID function. Okay, you will not need to do this at all, but it's a way to look inside Python and see, is it really at the same list or a different list?
John, one quick comment.
Yeah.
Because there are like so many output on the screen, it's harder to see which part is getting printed.
Okay, no problem, no problem. So let me turn off some maybe.
Yeah, and then if you can print it again. So.
Yeah, no problem. Yeah, like Manish is doing, please, all of you interrupt me, okay? Sometimes I'm used to seeing something, so I may not think of it, but okay. Is this any better?
Yeah, this is much cleaner.
Okay. So this is the part I was saying, right? That if you, I can just print a blank line here as well. Okay, so you can see that here, because I've rerun the program, Python still hasn't cleared its memory, so it's just incrementing the ID. So the list is given an ID of 8. Even though I modified the list, it still has the ID of 8. And when I create a new list, it gets an ID of 9. Okay, so that's all I want you to take away. So now I don't need to show you that part anymore. But now what I want to show you is that an important idea here, right? So I'm showing you that a list can actually store, for example, in this list, I call it a messy list. It has an integer and 2 strings and a float in it. So a list can actually store objects of different types. So now I'm going to tell you that this is not a good programming practice, even though lists allow you to do it. And why is that? Because if you try to do an operation that takes integers, it will break when you pass it the second argument of a list, right? So you have to do a lot of checking in your code. If a list has different types in it, you cannot easily invoke a function on the list or a standard manipulation of an item of a list. You'll have to check, is the item of the list compatible? For example, if I want to add 2 numbers, I can add the first element 1 to 5, for example. But if I try to add John to 5, it will break because it'll say you cannot add an integer and a string. So in general, Python allows you to keep multiple types in a list, but I would give you a programming guideline, always create lists with the same type. Now, this has to be taken with a pinch of salt. There are some cases where we can generalize. but that's for an advanced class. For now, always try to keep the same type of objects in there and makes your life easier. Okay. Now, important operations on lists is you can join two lists together. So this is important. It's the same operation as joining two strings together. It's the plus. So plus will always join two strings together. So I printed this. Let me just comment out the other prints as well. Okay, so you can just see this, right? I've joined two strings together, two lists together, and I get a third list, which is a union of those two lists. Okay. If I go now, I can just append. So for example, I can add. Append is important. It's a way to add an element to the end of a list, right? So if I run this, I can even append a whole list too. So for example, here I just appended the whole list in. This is not something you want to do. You don't want to create a list of lists. By the way, this shows you that lists can contain anything, including other lists. Very powerful idea, but you should not use it all the time. You should use it only when you really need to store lists of lists. But append will just take whatever you give it and put it as the last item of a list. So if I don't run this and just append 100, for example, then I get a slightly better looking list. Okay. What else? There is a notion of extend. So if I want to put two lists together, I can either use the plus or I can use this operation called extend. And extend will actually take the second list and add it to the end of the first list in a systematic way. So for example, if I run that, it just extends the list. Okay. After extend, there is insert. So again, it's a little tedious. I don't need you to memorize this. Just want to cover some important operations. Good to know what can we do to a list, right? So you want to insert an item. If you want to insert an item at the second location, so there's existing list, but now we want to insert a new item, right? So if you run this, for example, it will actually insert the number 200. So let's just look at this, what happens. See, after inserting 200 at location, so you see that here, there's the number 200 is in location 2. So that's what insert can do. And then you can just delete the second item from a list by doing this. If you print it, I don't want to run it. Yeah. So let me just run that. So you see after deleting, so you don't see 200 anymore. So del will delete items, and you can also remove a specific item. If you don't know where it's located, you can just say remove 100, right? So you can just remove any, but this is removed by value and this is removed by index. So notice the difference, right? So that's another important conceptual point. How can I access things by index and how can I access things by value? Okay, so that's at a high level. I don't expect you to memorize this, but of course I expect you to write programs that will use all this, right? So, and I've documented it a little bit here, and I've given you also the link to the Python documentation. So give yourself a little time. In a programmer's toolkit, all these methods will be second nature, right? But the way I want you to find these methods is when you're writing a program, think, oh, I need to append something to a list. Then say there must be a function which will do it, and look at, I usually try to use code that we've already seen somewhere in the course, right? So look in our course materials, you'll surely find it. Still don't find it, you can look in Python documentation. Okay, I try to make the course materials complete so you don't have to search everywhere.